So when you hear the word flood, what's the first thing that comes to mind? I'm guessing it's probably images of chaos, right? Destruction, water everywhere. But what if I told you that's only part of the picture? Today, we're going to peel back the layers and look at the unseen story of floods. We'll explore everything from their, believe it or not, benefits to how on earth we even try to predict something so powerful.
All right, so let's start with a really basic question. What is a flood? I know, it seems obvious. We all know what a flood looks like. But if we're really going to get to the bottom of this, we've got to start with a solid scientific foundation. It's more than just a lot of water.
Okay, so at its absolute core, it's pretty straightforward. You've got normally dry land that is suddenly not dry. It's covered by an overflow of water. Now, that water could be coming from a river that spilled its banks, or maybe it's super heavy rain that has nowhere to go, or it could even be a mud flow. But, and this is a big but, that's just the starting point.
And this is where we get into a really important distinction. See, just having water covering an area, that's technically called inundation. It's just submerged. It only officially becomes a flood in the scientific sense when that water starts causing damage. We're talking damage to property, to crops, to life. So the key thing to remember is this. It's not just about the water, it's about the impact.
Okay, so it's not like a flood is just a flood. Not at all. Think of it like storms. No two are ever quite the same. They come in all shapes and sizes, and understanding the different types is absolutely crucial because each one brings its own set of dangers.
So we're going to break it down into four main types. You've got your riverine floods, which are the ones that happen around rivers. Then there are flash floods, the super sudden ones. We'll also look at coastal floods, which are a whole different beast. And finally, the really rare but devastating ones, dam failures.
All right, let's compare the two big ones you see inland. On one hand, you have riverine floods. These are kind of the slow burn floods. Think of a river that just keeps rising and rising after days of rain or a big snowmelt until it finally spills over its banks. The good thing, you usually get some warning. But then, you've got flash floods, and these are the complete opposite. They are sudden, they are fast, and they are incredibly powerful. They happen with little to no warning, and they can turn a peaceful little stream into a destructive force in a matter of minutes.
Now, what about the coasts? Well, that's where you get something called a storm surge, and these are terrifying. When a huge storm like a hurricane comes barreling towards the shore, its winds are so strong they can literally push the sea level up, creating a massive bulge of water. We're talking 20 feet or more, especially if it hits during high tide. It's not a wave, it's a literal wall of water moving inland.
And then we have this one. Dam failure. Thankfully, this is super rare, but there's a reason the experts call it a catastrophic event. Just think about it for a second. The sudden, uncontrolled release of all that water held back by a dam. It's one of the most powerful and destructive events you can possibly imagine.
So we spent a lot of time on the scary stuff, the destruction, and that's all very, very real. But here's where this story takes a really surprising twist. What if I told you that floods aren't just about destruction? What if they're also a massive force for creation? Yeah, you heard that right. Let's dive into the dual nature of floods.
Just take a look at this. On the left, we've got all the losses we're familiar with. Damage, loss of life, business disruption, all of it. It's grim. But now look at the right side. This is the part we don't often talk about. Floods carry all this amazing sediment that makes soil super fertile. They literally recharge our underground water supply. And, there's even a human benefit. They can be a brutal wake-up call that forces us to get better prepared.
I mean, this isn't some new discovery. Think about ancient Egypt. Their entire civilization was built around the annual flooding of the Nile, which brought all that nutrient-rich silt for their crops. It's a totally natural process. You could almost think of it as nature's renewal system. For countless ecosystems, floods are absolutely essential for their health and regeneration. The problem, of course, is when our world gets in the way of theirs.
Okay, so if floods are natural, and in some ways necessary, but also incredibly destructive, what do? We can't exactly stop them from happening. Well, this is where the science comes back in. The whole game becomes about understanding and managing the risk.
And a huge part of that is this idea of a design flood. So when an engineer is building something like a bridge or a levee, they have a choice. Do they build it to survive the worst flood imaginable in 1,000,000 years? Well, they could, but it would cost a fortune. So instead, they design it to withstand a specific level of flooding, a calculated risk, all based on statistics and probability.
And that brings us to a phrase I am sure you have heard 1,000,000 times, the 100-year flood. But what does that actually mean? Is it a flood that's supposed to happen only once every century? Well, not exactly. To get it, you have to understand something called the return period. Now, this is not a schedule or a countdown. It's all about statistics. A 100-year return period simply means that, on average, a flood of that size has a chance of happening about once every 100 years. But, averages can be tricky.
Actually, there's a much easier way to think about it, and it's this number right here, 1%.
This is the single most important thing to get. A 100-year flood does not happen on a 100-year schedule. What it really means is that there is a 1% chance of a flood that big happening in any single year. That's it. So you could absolutely get 2 100-year floods in the same decade, or you could go 200 years without one. It's all just probability.
Okay, so if it's not based on a calendar, then how in the world do engineers figure this stuff out? How do they estimate the size and the likelihood of these floods?
Well, it's pretty complicated, as you can imagine. They feed a ton of data into these sophisticated models. They're asking questions like, how big is the whole area of land that drains into this river? How steep is it? How intense is the rain and how long does it last? And this one is huge. What's the ground like? Is it a forest that can soak up water like a sponge? Or is it a parking lot where the water just runs right off? All of that gets crunched to predict how a river might behave.
And all of this science leads to a really important shift in how we think about floods. We've kind of learned the hard way that trying to stop every single flood is basically impossible. In fact, sometimes trying to fight Mother Nature just makes things worse. So the goal today isn't to prevent floods, but to reduce the potential damage when they do happen.
Yeah, as the source material says, it all comes down to reducing flood damage through smart planning and mitigation. So what does that look like? It means not building in the most high-risk areas. It means protecting natural things like wetlands that act as giant sponges. And it means having really good warning systems in place. It's a total mindset shift, from fighting the water to learning how to live with it.
So here's where we land. We've got all this incredible science, right? We have tools to look at the past and calculate the risks, but, and this is the big but that the source material leaves us with, our climate is changing. The rulebook is being rewritten. Storms are getting more intense. Rainfall is getting heavier. So the big lingering question is, are all those calculations, which are based on the past, going to be enough to prepare us for the future? Are we ready for what's coming next?